I welcome Abhishek. So in this round, we are conducting this mock interview to evaluate AI observability and guardrails for a forward deployed engineer role. And we're going to get started with the first question.
How would you design observability and guardrails for a production LLM application serving enterprise users?
Okay, so this question has two part. The first one it would be the observability. So here, what I would be doing, I would be tracing every LLM call and tool call as span. It would have the prompt token, latency, cost, and status, and all would be kind of a rolled up into a full request trace, so that I can see the entire reasoning path, not just the final output. The layer in the metrics would have the task success rate, cost per task, latency per node, and some sampled production eval for groundedness or quality drift, not just for the uptime. For the guardrail layer, at the input side, I would validate and sanitize the user input. Mm, Then, I would try to detect the prompt injection. At the output size, the schema or the pedantic validation on structured output has to be done. Content safety filter before anything reaches the user, and a PII redaction for the enterprise data or whatever PII data is present in the system. At the tool call side, obviously a strict schema validation on the tool argument so that it doesn't hallucinate on the call and when it hit the real API, and it shouldn't hit with a bad parameter. Plus, there has to be rate limiting adjustment and maximum iteration, which can stop a infinite or a runaway loop. Or as this question is for enterprise user, so we can have a role-based access control on data and tool per tenant, and an audit logging for compliance and per tenant isolation, so that one customer context never leak into the another. So I would try. I mean, in a nutshell, I would try to design the both the the observability and the guardrail from day one, and it won't be a retrofit. So it would be an end-to-end from where the inputs start and to the output to the end user. Yeah.
Okay, sure. Let's get to the next one.
An enterprise LLM starts leaking sensitive data despite existing filters. How would you detect, trace, and harden guardrails without hurting response quality?
Okay. So in order to detect, as I earlier said, I would pull the trace for the flagged conversation, a full span from input to output, and would try to check the where the leak actually, entered. So was it in retrieved context, like track pull the data, it shouldn't have, and it has some, some context in it. The prompt where the user, extracted it via injection or some jailbreak like situation, or the model is synthesizing it based on the training data. So uh, it would be, it would be like a running a retroactive scan on the recent output log against the PII or sensitive data classifier, find out the how widespread it is, and within the system, not just one reported case. And then, you know, we uh, we could go for a trace, because since it's slipping in past the existing filter, the gap is likely, a coverage gap, not a total absence of guardrail. So we would check whether the filter is it's a regular expression, it's a regex or a rule based, which is easily bypassed via paraphrasing, encoding, or indirect ask versus a semantic classifier. Also, I would be checking whether the filtering happen only on final out or on the retrieve context before it reaches the prompt. A common miss is filtering user input and output, but not the rack context in between. So yeah, this could be the issue. So we can go for system hardening, uh, but here we have to keep in mind it shouldn't alter with the quality of the system or the output. A few things what we can do without hurting the quality is add a semantic or a classifier based output filter as a second layer alongside the regular expression. So rather than replacing it, filter at the retrieval boundary too, not just the final output. So it would exclude the sensitive field before they even reach the prompt. We can have a master user allow list based on the data access, only what field or what query a user can do instead of a broad retrieval, and I hope the filter catches it. And we can have an aggressive filter that can cause the false positive refusal on some legitimate queries. So so test it would test the false positive rate, not just the catch rate. So yeah, I mean this is how I would be dealing with this situation. So this is the reason why guardrail need to be layered. So it has to be at input, retrieval, and the output layer rather than a single checkpoint. Yep.
Okay, sure. Let's get to the next one.
How would you define and monitor guardrail effectiveness KPIs across latency, false positives, jailbreak resistance, and business impact in a production LLM system?
So here also for this situation, uh, I would start with latency. So there has to be a track added latency per guardrail layer separately at the input filter, output filter, and the retrieval filter. So I know exactly which check to optimize if if the budget, if there is a budget constraint. So not just the total request latency. False positive need to be checked. So let's say we sample a legitimate query that got blocked or flagged and track the false positive rate against a golden eval set, not just the catch rate. So a guardrail that blocks 100% of attack but also block 20% of real query, it's a business failure actually. So it would create real issue in production. When it comes to the jailbreak resistance, so mm, I mean, we have to maintain uh, a eval set specifically for jailbreak or injection pattern, and it need to be run regularly, not just on launch, and to track the catch rate over time. Also, also to track new jailbreak pattern discovered in production, so that the eval set keep evolving, and since the attackers adapt to the penetration of any system. So our golden eval set for specific for jailbreak need to be updated on each iteration. At the business impact side, uh, we can tie the guardrail metric to the to outcomes leadership care about, like incident prevented, compliance violation, which would avoided customer trust and escalation. So this would translate the technical discussion into the business language piece by piece. So we would keep the guardrail KPIs that need to be monitored as system, not in isolation. So it would be optimizing the jailbreak resistance in isolation that tend to increase the false positive and latency. So I would track all four in one dashboard and treat trade-off between them as an explicit measured decision rather than something discovered after the customer or the end user complaint. Yep.
Okay. Let's get to the next one.
Your prompt injection detector misses multilingual jailbreaks. How would you debug root causes and redesign observability to catch them earlier in production?
Yeah. We need to look at, for this particular problem statement, we need to look at the root cause. What could be the root cause of the issue? Like most prompt injection detectors are trained predominantly on English attack pattern because in AI also English is a dominant language. So suppose a non-English jailbreak just doesn't match the classifier's feature. So it's a coverage gap, not a logical bug. So I would confirm this by pulling the traces of missed jailbreak and checking the language distribution of what got through versus what got caught. At the debug level, I will look for the our architecture, the detector architecture. If the keyword or the if it is a keyword or regular expression based non-English variant, trivially bypass it. If it is a classifier, then I would check what language were used in training data. Also, we need to check whether the detection run on raw input or on normalized version or translated version. So if there is no language normalization step, then that's a gap. The guardrail need to be redesigned. So we need to add on language detection or normalization step before the index classifier, so that input is evaluated in a consistent representation. Or we can go for a multilingual trained classifier also. Uh, for the observability part, we can we can log the detected language per request as a trace attribute, so that we can slice the guardrail catch rate by language and spot the gaps proactively instead of waiting for an incident. We can obviously expand our master eval set to include multilingual jailbreak variant and rerun it regularly as new pattern emerge. And in case of an anomaly like unusual spike in specific language traffic paired with some flagged or blocked output, so that would be a alert, a leading indicator, not just lagging one. So this is a monitoring blind spot, not just a filter bug. So this isn't it only, patching the detector. It is making the language slice guardrail performance a track metric so that future gap like the surface on the dashboard. So yeah, that's how this particular situation I'll be dealing with.
Okay. Okay, let's get to the next one.
How would you run safe online experiments to tune LLM guardrails, balancing user risk, observability coverage, and measurable quality regressions across enterprise workflows?
Of course, uh, if we have to measure the quality regression across the enterprise workflow, so first we have to reduce the user risk uh, at the initial step. So we must never test a new or a loose guardrail on 100% traffic. We have to use it in shadow mode first, run the new guardrail in parallel on real traffic without acting on its output, just logging, what it would have done or compare against the current guardrail decision. Only after that look, if it looks safe, then I would move, a small part of, let's say, 1 or 5% of live traffic to it, and uh, which is gated to a low risk segment, internal user and non-sensitive workflow, before expanding to the enterprise wide. On the observability coverage during the experiment, what I would do is I would trace every request in the experiment group with same span structure as prod, having guardrail decision latency and tool call plus an experiment group tag, uh, so I can slice metric by variant, track the same KPIs from before, like false positive rate, jailbreak, catch rate, latency per variant, not just in aggregation. Uh, quality measuring the quality regression. As usual, we would run the golden eval set, the master eval set against both variant before and after rollout, and set an explicit guardrail on guardrail and automatic rollback trigger if task success rate, groundedness score, or false positive rate cross threshold versus the control group, then we do not rely on someone noticing the dashboard. So it would be a closed loop thing. For an enterprise specific care, I would segment the experiment by tenant risk profile. A regulated industry customer shouldn't be uh, in the same experiment cohort as the low risk one, and keep the control group large enough that a regression is statistically real, not a noise, before moving forward. The experiment itself needs the same guardrail and observability discipline as the production, but it would happen in a shadow mode with automatic rollback trigger and instead of manual monitoring. Yeah.
Let's get to the next one.
Yeah.
How would you design end-to-end tracing to attribute harmful LLM outputs to prompts, retrieval, tools, or model behavior in production?
Okay. So, so what we can do is we can, structure the trace as span tree with, let's say, one node per stage, not just some flat log. So a single trace ID per request with child span would have a prompt span, a retrieval span, a tool span, a model span. And let's say each, like, the prompt span would have the raw user input or any pre-processing injection filter applied or system prompt version used. Similarly, retrieval span will have the query send, the document return, or the source or doc ID's relevance score. For tool span, it would have similarly, tool name and input argument, output, success, failure. Uh, yeah, for attribution logic, uh, what I can do is with the previously mentioned structure, uh, debugging a harmful output becomes walk down a tree. So, I would check the model span first. So did model hallucinate from clean output or not? Then I would go for the retrieval. Was there any bad content injected? If not, then I would move to tools. I would check, did the tool return something it shouldn't have? Then to the original prompt, was an injection attempted or not? So each span, carries enough metadata to answer was this stage's input already bad, or did the stage make it bad? I mean, that's how we can track. For for practical requirement, every span tag with prompt or agent graph version and model version, so a regression can be tied to a specific deployment. Uh, Immutable, and there has to be a immutable append only trace storage. so that you can't debug an incident if traces can be altered after the fact. And there has to be a sampling, 100% capture of flagged or harmful output, sample capture of normal traffic to control the cost. So the core principle would be, the attribution is only possible if the trace preserves the stage boundaries. So a flat log here, here what happened can't simply answer which stage caused what. So the span tree itself uh, could be used as a debugging tool from start to end.
Okay, let's get to the next question.
How would you audit and continuously improve guardrails for agentic LLM workflows using human feedback, red team findings, and production telemetry?
Okay, so for continuously improving guardrail, I would treat it as a closed feedback loop with three input feeding one pipeline, not just three separate process. So first would be the human feedback here for this situation. I would capture the thumbs up, thumbs down, or flag conversation directly in the trace. Let's say some task ID linked to it, the root flag cases into into review queues, or periodically pull a sample unflagged traffic too. So I mean that would be the part of a human feedback. Let's say there is some finding, mm, you know, main we can maintain a versioned eval set where it has jailbreak, injection pattern, edge cases. So that's get a new entry every time a novel attack is found, and whether from an internal uh, exercise or real production incident. So every time it would catch something. So this eval set is the regression suite. So it would run before every guardrail uh, you know have any changes. For production telemetry, I would track the KPIs from before, like the catch rate, latency, cost, and false positive rate. Uh, and it has to be divided based on the task type, the tenant, or language, with alerting on drift if there is some drift. So this is what catches the gap, like multilingual, which we discussed earlier before the human reported. For closing the loop, all three sources must land in one triad backlog tagged by the severity or root cause. Input retrieval tool model layer using the tracing structure as mentioned earlier. Fixes need to get validated against the golden eval set plus the quality benchmarking before moving forward. Uh, rollout rollout has to be done in sequence, like from shadow mode to some canary, like 5 to 10% actual traffic, to full rollout. So same as any guardrail chain, and every fix get added back to our golden eval parameter as set as as a permanent regression test. So it would be like a closed loop. The guardrail only gets stronger over time. It never regresses silently. So yeah, that's how I would be handling.